Government Vidarbha Institute of Science and Humanities, Amravati. Department of Chemistry, Semester 1, Practical 2nd, Physical Chemistry, Part B, Exercise number 2, Non Instrumental, Experiment number 3. Hello friend, I am Sachin Bangade. Today we will start new experiment. We find out the strength of hydrochloric acid and acetic acid in a mixture of both by titrating it against sodium hydroxide solution conductometrically. Aim to find out the strength of hydrochloric acid and acetic acid in a mixture of both. Appropriate strength of each acid is n by 10 by titrating it against sodium hydroxide solution conductometrically. Before starting the experiment, we know that what is the strength of the acid. Acid strength is the measure of the ability of the acid to lose its H positive ions. A strong acid is the one of the completely ionized in a solution, whereas a weak acid only partially ionized. Strong acids are corrosive in the nature and causes several burns when they comes in the contact with the skin, but weak acids are only mildly corrosive and are even present in our food and body. Hydrochloric acid, sulfuric acid are the example of the strong acid. Ethanoic acid, citric acid present in the citric fruit and acetic acid present in the vinegar are the few examples of weak acid. An acid having a greater degree of dissociation behave as a stronger acid. Now let us understand the factor on which the strength of acid depends. The degree of dissociation of an acid depends on the following two factors. Number 1, strength of H-A bonds. Number 2, polarity of HA bonds. In general, weaker the strength of HA bond, stronger is the acid. Similarly, greater the polarity of HA bonds, stronger is the acid. Both of these factors make the dissociation of acid molecule into H positive and A negative easier, thereby increasing the acidity. When comparing the elements in the same group of the periodic table, the strength of H-A bond is more important factor in deciding the acidity than its polarity. As the size of A increase on descending a group, H-A bond strength decrease and therefore the acid strength increase. Apparatus and chemical. Conductivity bridge, beaker, thermostat, measuring flask, stirrer, etc. Chemicals: sodium hydroxide, hydrochloric acid, and acetic acid. This is the image of conductivity bridge, beaker, thermostat, measuring flask, and magnetic stirrer. Theory: this type of titration is just a combination of two separate titration, HCl against NaOH and acetic acid against NaOH. By adding alkali to the mixture, the conductivity of the solution decreases due to the replacement of H positive ions from the strong acid. It then decreases as the weak acid is converted into salt and finally rises more steeply as excess of alkali is added. A curve is plotted with the conductivity as the ordinate against the volume of alkali added as the abscissa. It is observed that there is a rounding off at both the end point. Usually, extrapolation of the straight line of the three branches would lead to a definite location of the end point. It must be noted that the first end point will be that of hydrochloric acid strong, while the second that acetic acid weak. Procedure: prepare and extract n by 10 solution of sodium hydroxide. Rinse and fill the burette with the alkali solution. Now take 5 ml of the mixture of HCl and acetic acid in a 400 ml beaker. Add about 100 ml distilled water. Dip the electrode of the conductivity cell in the solution of the mixture. The first endpoint will lie near about 5 ml, while the second will be near about 10 ml of sodium hydroxide solution. Now the resistance of the solution before adding the alkali. Now add 1 ml, 2 ml, 3 ml and 4 ml of alkali from the burette and shake the content of the beaker thoroughly. Now add alkali at an increment of 0.2 ml up to 6 ml and then again between 9 ml and 11 ml. After adding 11 ml of alkali solution, add 1 ml in each addition till you have added 50 ml. Note the resistance of the solution after each addition and thoroughly stir the content of the beaker. Observation: volume of mixture taken is equal to 5 ml. In observation table, there are 4 columns. Number 1, serial number. Number 2, volume of alkali added. Number 3, observe resistance in ohms. Number 4, observe conductivity in ohms inverse. N1V1 of HCl is equal to N2V2 of NaOH. N1 into 5 is equal to N by 10 into V2. Then we get N1 is equal to N into V2 upon 5 into 10. Equation number 1, strength of HCl is equal to 36.5 into V2 upon 5 into 10. Equation number 2, N3V3 of acetic acid is equal to N4V4 of NaOH. Then N3 into 5 is equal to N upon 10 into V4. Then we get the value of N3. N3 is equal to N into V4 upon 5 into 100. Strength of acetic acid is equal to 60 into V4 upon 5 into 10. This is the expected graph, conductance versus volume of NaOH. It gives two endpoints, first endpoint and second endpoint. Titration curve for mixture of acids. Result: after this experiment, we get strength of hydrochloric acid and acetic acid. Book suggested by university. Thank you.